Yeah, so guys, we are live. So this is actually part two of solving today's Leetcode problem. Actually, yesterday now, I'm not sure if time allows me to submit it. So what the problem says, so we actually had an attempt earlier, and I found that this problem was not fitting in the constraints. So I went to see the editorial. I did not see the code. In the editorial, I found that they have a solution which is actually brute force. It is not an optimized solution that passes the standard limits like 10 to the power 6 number of operations or 10 to the power 7 in at the worst case. So this was having a brute force solution where the actual complexity of this problem is 9 factorial to the power 9. This is also a big number. We will code in the video I have discussed. I had come to an approach where we are having some b to the power b factorial to the power 9 solution. I mean 9 factorial to the power 9 is the one, right. So this is the same thing which we have discussed, right? So this part of video is actually an implementation of that. So we will move to the screen and we will decide an implementation approach, how to actually code this up. Okay, so let me start sharing my screen of my iPad where I can use a pencil to solve this question. So let me accept the screen. Yeah, I hope you can see the videos coming to the screen, right? Okay, guys, so let me erase some part of the things here. Yeah, so for briefing you about the logic, so the Leetcode standard editorial said 10 to the power 27 solution is acceptable for this problem. This is crazy. So what I did was I earlier started with a brute force, which was 10 to the power 81, or you can say 9 to the power 81. Then I brought down to something which is similar to 20 to the power 27, and I gave up. I thought that this problem is not solvable under these constraints. I cannot drop I cannot drop down 20, 10 to the power 27 to something 10 to the power 7 or 10 to the power 6. So that so I decided to check the editorial, like if there is a groundbreaking solution which exists to this problem. So I came to know that they are actually focusing on 10 to the power 27 kind of complexity solution. And we were also doing this. We were doing recursion plus optimized backtracking. Like backtracking is really cool here. Recursion is really cool here because we are not exploring all 10 cases here. We are exploring the cases which are accepted. And the beauty of this problem is this, that you have 9 possible cases for this cell, and when you fill these cells, you're actually reducing the time complexity by lots of folds. So you see 9 is here, and when you come to this cell, you are left with only 3 options, things like that. So why? Because if we have filled these cells, the additional constraints which apply to this cell reduce the number of possible operations here. So now it's time to figure out how we can code this up. Yeah. So how we can code this up, that we have to figure out. So here there is no DP involved because recursion will itself more or less handle everything. Right. Memoization is not going to help here because kind of recursion itself is having the, yeah, let me think of it. Can we use DP here? So recursion states, can they be cached? Is there any meaning to a particular configuration? No, right? So basically, it's more like this. We start with all cells empty. We fill the first cell. There are 9 possible ways, right? And then for each possible way, we go to the next cell and we fill it. So it's more like we go from cell number 1 to cell number 81. We figure out what are our I and j's, right? Then we figure out what is the set, what is this set, which is basically the optimal set of parameters here. What are the optimal set of parameters? What are allowed set of parameters for this set? And then we do the brute force part here, right? This is a simple brute force, man. If I just go ahead and code it now, I will show you what happens. So this is a very simple brute force. Why I said it? Because we will be moving from 1 to 81, right? For each, and you have this grid with you, right? For each number, or for each level, let's call this level, you find out the possible slash allowed values. So for that, you have to check at the row level, at the column level, and at the box level. When you check these 27 values, you'll find that out of those nine, uh, out of those nine, we are kind of yeah, we are kind of left with some set of values here. Right? So what can happen here? So first case is that this particular cell is already filled. In that case, we will just skip and move to the next state. Now, if it is empty, so we have the I and j's. So we check at I level what values we are left with. We check at the j level what values we are left with. And then we check this level. So this is really important. So let's say, sorry guys. So if we are moving from 1 to 81, probably we are moving like this. So at any point, we will go and check the 3 cells which are up. That will make the grid for this, because below cells are empty. So that makes sense that because we just check the upper cells. No, that's not the case, man. Since these can be also filled, so I'm saying like this: if this cell is under consideration, so it is part of this particular box. Okay, it is part of this particular box. It is part of this particular box as well. It is part of this particular box as well. So for this box, some values will be filtered out. For this box as well, some values will be filtered out. You see, this is a really good problem, very good problem. I won't say it is a hard problem, but it is a very good problem. So basically, for this particular cells, we have to consider all the values, and this is a very challenging part of it. So which 3 cross 3 boxes it can be a part of? No. Let me think it in a different manner. So this is not. Let me go to the constraint here. So this third part is that there are only 9 sub boxes. Okay, so we just don't need to worry about everything else. So this particular number can be part of one cell, one such cell. Yeah. So for this makes our problem very simple. So if I come to this part again, so let's come to this part, this cell again. So I don't have to check this much. I have to check that. So this is a 9 cross 9 grid. Which grid number this particular value is there? So that we can easily identify. So if it is in the probably yeah, actually yes. So we have to think of it. So let's say we figured out I and j. This is I comma j. And if you talk about zero indexing, that will be better. So let's come to this part here. So let's call this 9. Yeah, 9 here. So if our I is something like I will help us identify. No, so I is there. So I will help us identify that upper part of it. So let's say if I is in 0 to 3, I in 0 to 2, 0, 1 and 2. In that case, we will start from x, which will be 0. If it is 3 to 5, x is equal to 1. So we can see that this is actually whatever I divided by 3, right? When I come to 6 to 8, yeah, that will also give us 2. So I divided by 3 will give me our x. Now if I come to y, which means that we have to start from this particular x, right? Go from x plus 1, x plus 2, and now let's figure out y. What will be y? So y, right, y. So for 0 to 3, 0 to 2, y will be 1. Similarly, like, so this will be y equals to j by 3. And yeah, this will be y plus 1, which is y plus 2. Yeah, this is only 27 values. So I am clear on this as well. So what we will do now, let me figure out, let me talk about the approach overall. So if I talk about the recursion approach, we will start from 1 to 81. For any level n, we figure out what is I and j. How do we figure out that? So 1 till 9, 1 till 9, I is going to be 0, which means we can start from 0 to 79, sorry, 80. This will be 0 to 8, right? So we can just simply do I by 8. So I by 9, it will come at 0. Sorry, n by 9. So this is I is n by 9. Similarly, j is like, let's say we have 2 here. So yeah, I mean, let's say we have the second cell here, so which means that n is equals to 1. And for that purpose, what will be our j? I is clear to figure out that I is something like n by 9. But this part is actually important because it has to be the same. Right, so it is this. It is probably uh, mm, let me think here. I is n by 9 for sure. Now if I talk about j, there are two parts. First, figure out which. So you figure out I. Yeah, so j is basically the modulo, right? For modulo it will work. I hope it will work. Because if we are at the second level, second cell, this will be 9, this will be 10. So 10 means it is 2. So 10 modulo 9 if I do. Second place, which is I, first index, this will be 1. For 11, I expect 2. So 11 modulo 9 is again 2. So yeah, this is n modulo 9. Then we are clear about this. We care about I and j. Once we're clear about I and j, we can form that set. So we check at the I level and we check at the j level. We get this set. Then then we form x and y here. X is like we discussed. So x and y are basically the 9 cross 9, sorry, 3 cross 3 cell. So x is basically, like we figured out, I by 3, y is also I by 3. So we'll get some starting point here. This is x comma y. Sorry, my handwriting is a little bit weird. So yeah, this is x comma y, and we can just continue in this manner, like xy, and this will be x plus 1, y plus 1. Sorry, this will be, yeah, from x will go from x to x plus 2, y will go from y to y plus 2, and that way we can figure out things. Then we can refine this set. Once we get the set, we move to the next state. So let's define the state as well. So it will be level, which will be level plus plus. Then grid will be the grid itself. It is a memory by passed by memory operation here. What else? That's it. That's it. Because I and j we figure out, and at any moment, base case would be that. Base case would be what? Yeah. Base case will be where level is equal to 81. There we will surely have an answer. Otherwise, we will just return. If there is this set gets empty, we'll just return. So yeah, I am done with my brute force approach here. Now let's move to the coding section. So if I open the code editor, let us code it up. How are you going to code? That's clear to me. Now I have to define those things here. So we will start with 0, level equals to 0. Let me write comments here. Level equal to 0 all the way up to 79. Sorry, my bad, not 79, 80. Right, so what I'll do, I'll just I'll return this board. So basically I'll pass everything from memory and return like this. So here what I'll do, I'll just define a recursion where I start with 0 and turn up the caps lock. I'll start with 0 and I will basically do what? I will start with 0 and I'll pass this board. That's it. That's my recursion here, guys. Now let me define this recursion. So this is also void because it is not returning anything. It is editing that by memory. Okay, editing the board itself by memory. So what are we doing here? The moment we reach 80, that will be our last state. Okay, so here we have integer level. Let's call this L. And we have integer, sorry, not integer, we have vector of chars, which is our board. Let's call it B. So we are using this ampersand because we are passing things by memory. So in your language, it might be different. So in Python, it is something else. Let me check how to pass in Python by memory. So you can also check these things on the internet and find out. Let me see any of these. Pass by object. Okay. Yeah. So Python uses a mechanism often described as pass by object reference or pass by assignment. This means that you pass an argument to a function, a new reference to the same object in the memory is created. So when we pass and assign to the parameter variable within the function scope, which means that it has already that thing already by default, I guess, right? So variable is already holding a reference to the list object. It is not the list itself. Okay, let me ask it, how is it different, right, than C++? So this is an exploration, guys. Just my curiosity is letting me explore this. How is this different from C++? Hmm. In Python, variables are not fixed memory locations. They are names that refer to objects in memory. C++ gives us explicit control over how arguments are passed. So behavior with mutable objects, behavior with immutable objects in Python. In-place modification are visible outside the function. What do they mean to say? Does not affect the original value. Okay. Yeah, this is not rendered properly, I guess. Yeah, PR means basically, yeah, it is some HTML or some Python syntax, Markdown syntax to be honest. So this is the def function and number is 99. My num is equals to 10. Reassign number function is here. My num is still 10. Okay, so here you reassign this number, but my name is not changed because my num was holding a reference to this part. My num was 10. Yeah, so this is a copy. Hmm. Hmm. And here, what they did, they appended 4 in this here. Oh, right. Minus equals to 1 to 3. Modify this list. Yeah, correct. So variables are not fixed memory locations. They are names that refer to the objects in memory. This is really confusing, man. It's in a summary. Implicitly switches behavior based on the object's type. Okay. For mutable it is different and immutable it is different. C++ provides, yeah, these methods. I know that. I'm using one of these, right? The object's mutability determines whether it can be changed in place through the past reference. So yeah, this depends on the object, right? Assignment, a new assignment to the parameter always defines. Let me ask a clarification question. So you are saying that in Python, it is hard to tell if uh, it is passed by reference or not. I mean, uh, mutable will get changed, immutable, immutable's copy will be. You're correct that practical behavior of parts can feel ambiguous compared to C++, correct? It is not it is not that it's hard to tell, but rather the rules are different. Okay. Uh, mutable will get changed. Correct. So if you use list, we can pass this in functions flawlessly. It will not be a copy, it will be basically changing the existing object, right? So then we have to create a copy if we want to send it in a different manner, right? What happens with the reassignment? Immutable's copy will be changed. What did I say? Did I say the same thing? Which has removed my. Yeah. But it's more precise to say that reassigning an immutable object create a new object in memory. Okay. So yeah, I got this. So Python, it is basically you have to find which type of data types are immutable and which ones are not. If it is immutable means we cannot change that object. So there it will be a copy, which will be basically. Oh, let me ask that. What are mutable and immutable objects? Py Python. um. Yeah, list, dictionary, and all. What are immutable? What are immutable? What is immutable? Mutable is here. Yeah, immutable is this. Yeah, tuples, I know that these are immutable. So string is hello when I add bold to it. New string is this ID concatenation, original ID, ID. Okay, this ID is resulting in different ID. What is an ID function? Wow, that's really object ID, right? That's really good. So the variable name has switched. Mm-hmm. Earlier it was storing this ID, now it is storing this ID assigned to the same variable name, right? Okay, so this is the case. So when we pass this true function, actually a new variable is created, stored in some other name. This is really interesting. So guys, if you are a Python programmer, you should really care about these. But yeah, we are sure that this is passed by reference, which means that the same board variable is edited. We don't need to worry about if it is getting copied, and this particular board which I'm returning here is actually an initial configuration. No, it's not, because the initial configuration was this. I passed through this function made some changes, that was applied to the same variable because it is passed by reference, and then I return the board. Okay, this makes sense, right? So now what we do here is this. We do this n equals to, oh sorry, L is equals to this. So first we find out our i's and j's. Okay, as discussed, I is simply L divided by 9, floor division, and then we have j, which is L modulo 9. Then we have x here, which is I divided by 3. Then we have y here, which is j divided by 3. Right. Now, what I'll do here, let me define a set of characters. I hope I can define in this manner. So here I will be defining 1, 2, 9. Oh, this is really cumbersome, but I have to do this. 4, then let's go to 5, then let's go to 6, and let's go to 7, 8, and 9. So now we will create a copy of this set, which will be auto, what should I call this? Let's call this char set cs, and this will be st. Right. Now it's time to remove the values. And we have to also add a base case here, which is if L is greater than 80, which means we have exhausted everything, we simply return. And here one more case will be added. If st is empty, we won't be proceeding further. Okay, so if sts is empty, then also we return. Now let's form the cs. So what should we do here? This is at the row level for auto x, not x. So if we are doing at the row level, which means that j will be changing, right? J will be changing from 0 to 9, and it might be the case that board is empty, so we have to handle that. So if so here we will start with some variable which is t. Yeah, so this t is, wait, it is starting from 0 and it will go to till 8, and let's do row and column together. Makes sense. So if board I and t is not equal to a dot, right? In that case, what we will do, st dot erase What will we erase? We will erase by finding it, because it might be the case that it is not there in the set. We have already deleted it. Then it can raise errors, right? So we find, what do we find here? B of IT we find. Okay. Same goes for the other way around, where we have BTJ. If it is not equal to dot, then we are doing something here. We are doing this erase operation, st dot find B of T and B of J. Correct? Okay, so this is there, and then we return it. It is empty. My bad, this is not st, this is ct, because sorry, cs, because I defined it. Sorry. Okay, if it is not empty, what we will do in this case? Oh, sorry, there is one more case, which is the which is this set here, sub boxes. So here we are clear that we will start from, let's call this t equals to x. We'll start from x. T is less than x plus 3, not 2, 3, and t plus plus. And here we are going to need one more variable. Let's call it u, which is again y. U is less than y plus 3, q plus plus. And what we do here is this. We do this the same thing. cs dot erase, cs dot find. What we're going to find here is this. We find, yeah, we find b of t. No, we find, yeah, b of t and b of u. But we have to erase it first. So we have to check if it is a dot or not. So that is also fine, because it is covered in dot find operator, right? Now just we move to the next states. If it is not empty, then what we have to do is this. We have to fill it, right? For auto c inside cs, we do this board of b of I j is equal to c, and then we just go to recursion. Yeah, recursion of level plus 1, and the same board. When we come back, we reset it back to what it was. So b of ij is equal to dot. So this reminds me of a very important thing, which is this. We have to not return, we have to advance, right? If it is already filled, we have to advance. So here only I will be adding that. If already filled, skip it. So if b of I j is not equal to dot, then what we have to do, we have to move to the next level with the same configuration. Correct? So yeah guys, this is the code. I don't know why my code is really small. Let's check if it works. I'm returning board. Okay, so I don't have to return anything, because they will be reading it by default. Sorry, I did not see this void. I actually saw that, but I did not focus on it. It is giving me a runtime error. Where exactly? Okay, here it is giving free on the address which was not malloc. Okay, so I think it is wrong way around. Oh, I think so. Let's see. Makes sense to me. So I'm just making sure that I'm not. Okay, so let me see this if it is good enough. I don't know. So here it is PU is not equal to CS dot and let's check this up. Great. So the output is this. Huh? Oh, sorry, that is my bad. If I'm changing it in place, return and then it will come back to smaller state. Yeah, instead of returning, we have to solve it. We have to basically save it somewhere. How can I save it somewhere? Huh. Right. So I have to create a vector and vector hash. Sol is equal to the current board configuration. What the heck? How did I replace this 5 with a dot? Because I'm not editing it. Oh, sorry, my bad. Here we have to return it as well. Yeah, move to the next state and then return. Probably sol is not dead, but how do I know if it is solved? Yeah, I can do that as well. So it's like this. If let's call this bool sol equals to false. I think it is cool. If sol is true, return. Let's test it up. Now it is giving me the existing input, right? It is not filling it with numbers. So there's some problem here in the code. Let me check what it is. So this sol is thing, sol is a thing, right? Let me do this. If it is already filled, skip. So we're going to the next level with same configuration and then we return. Makes sense to me. So this ST is here, probably T ID is here, correct? TJ is here, this T is behind, J is constant. To start from 0 all the way up to 8. Good thing to have. It is not equal to dot. I think, yeah, this is enough. We don't need to check this. Because it will not be there in the CS set. If that's the case, right? So CS is ST, a copy of ST, and then we go. I can remove these. These really don't matter now. Looks good to me. Let's see what happens next. Y plus 3, we go to y plus 3, u plus plus, t plus plus, u plus plus, right? Tu is here. If it is empty, then return. Which means that is this is dead end and what return. Then we go inside CS, whatever is left in CS, and this part is also not valid. Then we go to recursion of level plus 1, comma b. B of ij is set to dot because it was what previously. We changed it to C. Yeah, this looks good to me. Let me check what is getting wrong. So for that I will use some print statements. For now this is enough. Let's see this over here, man. Okay, so it is actually going to these levels. It did not go to 81, go to 81, but it is actually doing this. Level plus 1 I'm doing right, and we are doing it as well. So 0 is straight away skipped because that is filled, 1 is filled as well, 2. So if you are filling, we can try it actually, if you are filling it. Okay, see out. Filled with joy. Okay, let's come here. It is filled with 1, which is correct. Then we go to level 3, which is filled with 2, which is again correct. What happened here? It went to the 5. Why did it skip? This level part is really crazy. And yeah, if it is empty, we have to find out. So in that case, it will not fill it with anything, right? So for this, what happened? Like, yeah, here we can see that if we fill with 1 and 2 over here, and then so this is already filled. 0, 1, 2, 3, 4. 4 is already filled. It went to 5. 5 को इसने fill किया 4 से, like 4 is filled over here. Then it went to 6. 6 को भी fill किया. 7 has also been filled. Then it didn't go to 8. Why? It went back to 6. Here's the numbers which it had filled. Let me switch to the screen where I can analyze this test case. Okay. Let me do it. Okay, so right, so what it did, can I see that? No, I cannot. Let me do anything. Wait a minute. How can I do this? Right. Oh, it's hard to actually check. This is replaced. Yeah, this is replaced. One sec. Okay, so what should I do here? I should write it myself in this iPad and then I will show you. So first it filled the second index with 1, third index with 2, fifth with 4, and then it came to sixth index, right? 0, 1, 2, 3, 4, 5, 6, 7. So fifth was filled with 4, right? Sixth was filled with 7, and seventh was filled with, So it didn't went to 7. Okay, why did it not went to 7? Now let's explore that. Cool. So here we can see that for 7, what are the options left? 1, 2, 3, 4, 5. Wait a second. Why did it fill? Why did it fill with 7? No, no, no. Sixth was okay. Six was filled with 6, and 7 was also filled with 6. This is scary, right? This cannot possible. This cannot be possible. Because I equals to 0 and t will be hmm, I don't know, man, what is the case here. Let's check it. Let's let's print the CS. I don't know how to actually do it. Auto X inside CS. Not X, probably X we are using. C inside CS. What we will do? C out C and let's check it. How is it actually happening, right? Yep. Okay, so we come to the 0, 1 are skipped. We come to the 2 and we have options which is 1, 2 and 4 and we fill it with 1. Great. Then we have 2, 6 for this position. Great, we fill with 2 and then for this position which is 5th index we have 4 and 6. So 1 to 4 was here. We filled 1 quad here, 2 quad here. Then we have 4 and 6. And then we come to the 6th position. Here it was only 6, so we fill with 6. Then we come to 7th position. So here there was nothing. So why it filled with 6? That's a crazy thing to ask, right? So let me think of it. 7th की part पे आया हम सब में. Whenever I was at 7th level, so the C was empty, right? So if this loop did not run, this will also not run, right? Yes, it will not. So why is it filling with some C or so? So let's call this like this, filled that's a good thing. Question is why it did not proceed ahead? Why, yeah, why we did not get the solution here? Can I? So we did not get a solution. So why did it skip? So why did it not go beyond 80, right? Oh, my bad, my bad. So if we are not filling it with anything, in that case, what we have to do? We have to just return, right? No, no, no. In that case, right? So I just want to check that for this particular level, we had three options, one, two, four. So for two, if I check for two, yeah, I'll just search for this. So it had, I'm sorry, yeah, it had filled one, two, and four. All of these combinations are tried, right? It tried all the combinations. So, which is a good sign, not bad. For this, actually, there will be a varying case of inputs. It is 7 times depending on the right whatever thing which are applicable for this. First, check if our these loops are working correct or not. So if I go to this part, 1 to 4 was predicted here. So 1 is not here in this row. 1 is not here in this column. Neither 2, neither 4. And this cell also. So I think this is correct. Row and column sub boxes are correct. We are getting a good kind of CS here. The final answer, it is 4. So with 4 we might expect that things could have gone better, right? So what has happened with 4 was this. Why did it stop trying after this point? That is a question, right? So here it was empty and it started with another case of set of values. But why did it stop? That's the question, right? So let's say if we fill this with something and we move to the next state. The next state CS is all brand new, right? So which is cool. Why is it returned? Why is it not? So it could be the case that really hard to think. So we are not. So this will be a dot, right? And let's say CS is empty. Okay, okay. So let's start with this. For a particular case, if CS is empty, then yeah, you know what will happen? Ideally, what should happen if CS is empty means it's a dead. You have to go to the first point, right? So let me check what is happening here. So when it started with 4, it filled the other cell with 2, so which is not good. It should be 6, right? So yeah, it filled with 6 here. Mm-hmm. And then it filled the other cell which is 4 and 5 are skipped here. No, no, 5 is not skipped. For 5 we got only one option, which is 2, which is strange because 5, 3, let's say 5, 3, 4, 6 is followed, right? 7 is there. And for the next index, what we had earlier, yeah, so we cannot have 1, we can have 8, but we could have 8. Why 8 was not chosen? So here it should be actually 2 comma 8, right? Because you see 8 is here, right? So which means there's some serious problem at this point. So it actually deleted 8, which means that yeah, I would like to see what is the ing for this term. ijxy I want to see here. Right. See out ijx. I don't know how my debugging strategy is good because you have to use the print statements to debug, right? Let's check. 4 and then 6, 8, and here we are at this part. So it is 0, 5, 0, 1. This is wrong, right? Because x is 0, y is 1. This is not correct, man. Okay, so I get this. So basically, this is a problem, man. This is really the problem. Modulo 3 should be there. No, not modulo 3. But it should be the starting point. Like, there was a misassumption, right? So 0, 3, and 6. 0, 3, 6. These three was expected. So what could I do here? J divided by 3 will give me that. No, it will give me 2 or something like that. So it should be like this. J by 3. Wait, J by 3 is 0. So I want to have this, right? I want to have this for J 0 to 2. It should give me 1. For 3 to 5, it should give me 3, not 2. Currently it is giving me 2. Okay, currently it is giving me 1, right? Which is not correct. So what should be the case here? 3 to 5 के लिए मुझे 2 चाहिए. Plus 1. No. So 0 to 2 के लिए I need 0, not 1. For this I need 2. I mean 3 to 5 के लिए 0, 1, 2. 3 to 5 के लिए I need 3. And the next one, which is 6 to 8 के लिए I need 6. That I need for sure. I need that. Cool. And if I talk about I, so if I talk about X, X is good, or X के लिए भी same pattern, right? Same pattern for X as well. So if I have to actually, yeah, this part I messed up. So what happens in this case? 5 by 3 is actually 1, not 3. So what mathematical thing I used to get this, right? 6 to 8. I can hard code, definitely I can hard code it, but how can I get this? 5 से 3 कैसे मिल सकता है? Yeah, it is something like okay. So if I divide it by 3, I'll get 0. If I divide it by 3, I get 1. If I divide it by 3, I get 2. This is essentially multiplied with 3. right? So this is the logic which I had to crack, right? Multiply with 3. Probably, yes, it is a multiple of 3. So this part I am done. So I hope this is correct. Not I hope, I am sure it will work this time. And there we go. So we have some values which are filled, right? And this is hell lot of cases. Wow, I like it. But this will be 4 only. I'm sure about that. What it is 3. So it is trying 1, it is trying 2, it is trying. What it is trying? What is it trying? Uh-huh. Wait, I can't see the third one. So it did not try 4. Why is that so? 4 तो try करना चाहिए था इसे. So it got an answer between. समझ गया. There are some more, but the question is, it actually not did not. Why it is empty? I think all the cases are considered valid, but why is this empty? If sol is there, then we return, which means that the moment we hit that case, this cases will be okay. This is not a good thing to have. So instead of sol, I can do this that if it is there, then return, right? So instead of sol to be this, what I can do is this. Create a sol like this. Yeah. And sol comma b set kar diya. When it is set to b, I will just do this part here. Board equal to sol. You see, wow, this is really, it really feels good to code, and to be honest, it is a very less amount of code than it actually is. In other solutions, right? So let me just quickly remove these things here because this will really slow it down by a lot of words. Okay, this is also C out, and this also C out. C out, go ahead. Let's check this again. There's no std out, and I just submit this up. If it gives me a TLE, that's not my fault, by the way. I mean, really crazy, bro. Why is this TLE? That guy had hard code in it. If I analyze the complexity, I don't think it will be able to. It is just using an LLM under the hood. So I don't know. This is a really complex problem. Oh man, this is 9 times number of empty cells. So this is really crazy. 9 times number of empty cells. No, this is not true. This is not true. It is really hard to understand why it painting or so. If I go to editorial, let's go to editorial codes. And yeah, This is 37. If I go to 37, do we have it? Oh, it is not sorted, or is it sorted? It is sorted, I guess. Right, sorted. Let's go back. This guy has put that solution. Can I open this in the new tab? No, no, no. I can open here only. That guy is goodbye here. Yeah. This is basically the tutorial itself. Somebody has pasted it. C++. Here we are. Place number, backtrack. Yeah, we are also using the backtracking principle here, you know. This will not be the case. Let me just try doing something. If I copy this part and ask ChatGPT, wow, my internet is really fast. This is code 1. Then we go to code 2. Code 2 is my code here, which is this code. Are both codes identical in terms of time complexity? Let it figure out, because it's very hard to check this code. It is defined in some weird manner, I guess. What are they doing here? We can check meanwhile. So n is probably 9, so it is going to this. If it is this, but even though the worst case is same, right? Code 1 with row call boxes. Okay, so this is the order one, right? Okay. Pre-computed constraint tracking, right? That they have done. Yeah, this part, right? That I can optimize, right? This part I can optimize also. So they are saying that this part can be optimized. This part, really, this part. This is order 27 over here. So this can be brought down to order 1. How is this possible? Because we definitely need values, right? It could be order 9 or something. Okay. Let's see what is happening here. This is really a weird problem, guys. That is why I'm using ChatGPT. Otherwise, I could not have. If I think, how can they pre-compute it? This for a specific configuration can definitely cache it, but really hard to tell. This guy is really mad. O5 is really worst. Modify code 2 means modify it. Do not replace it. So so what it is doing here? Probably yes. 81. Really crazy, by the way. Yes, I already spent a lot of time. So guys, if I tell, I think brute force is ready. This part I have to look at. But it is really, really not making sense to me, to be honest, because you're not reducing time complexity by some folds. It's just 27, or 27 is changed to order 1. For this, I have to do all of this stuff. Let me try this code. Well, actually, guys, I'm done with this solution. I'm done with this solution. My solution stands at this point. This is something which I'm not. This is not me. This is ChatGPT just to validate that only order 27 is rejected and order 1 is accepted. Okay, so we got one more TLE, probably yes. So yeah, you see. My God, this question is really, really not a Leetcode question. I should actually report this up. Can you report this up? Clearly state where is this reporting part? There's a like dislike but option. Yeah, here it is. No. So the description does not tell that you are expecting 10 to the power 27 order of solution. Does not tell uh, you're expecting. Even the brute force solution which I coded was slightly poor than uh, even the brute force solution which I coded was slightly poor than 10 to the power 27 solution. It did not accept it. How would I know you want 10 to the power 27, not 10 to the power 30 or so? Slightly poor than 10 to the power. Yeah, this is tell you Leetcode is expecting poorer, right? Let me check. Yeah, let's do it. Let's do it at GitHub. Submit this here. There's a guideline before we contribute here. Let's say guideline security best space. So this is some standard guide, right? I don't know. Missing test case is not the case. Loophole is there. Let me just check the contributing.md file set. I can say constraints, right? Problem contents issue. Yeah, missing constraints, right? Yeah, I will just create a new issue here. It's Japanese, yeah. Bug is here. Title is here. The bug is that missing constraints. Title is the problem title, which is I can copy from here. Oh, it's good to check if there are existing issues, right, for this. So discard at the moment. Yeah, let's search it. If somebody has raised it already. Yeah. There's missing test case. It was opened 9 hours ago. Correct. I don't have time to read this, by the way. This is so used. I can do one thing, which is I can check the closed ones. Missing test case. Really? How was it possible? Wow, this is a great read, by the way. Yeah. Right. So if I go to this part here, uh, which was closed 7 hours ago. Oh my God, this is really a very big question. So this is a very really old problem, and many people have raised many cases here. Okay. What the heck is this? Do we raise request like this? Okay, let's see by comments which has the most comment. MIT Pro. Okay, so there is no point doing this stuff. My concern is only that you guys are expecting a 10 to the power 27 solution, and normally when we solve it, we get TLE, right? So Leetcode is not really, maybe I'm not aware of these things, like how Leetcode operates, but I can say that Leetcode, you should mention that you are expecting a brute force solution in this case. Okay guys, so this was it. This was it for today. I think we already got the problem of the day, which is which is not Sudoku solver for today, I guess. Okay, I think that brings us to the end of this video. And if I go to algorithms live channel here, I'm actually sitting for, man, I'm actually sitting for 2 hours now. Why my internet is so slow? My God. This is not today's problem. Today's problem is something else, which is yeah, maximum average pass ratio. So we will connect this, like we'll connect at 8 p.m. or 9 p.m. to solve it up. Till then, goodbye, take care, and bye bye. Somebody has subscribed.